Okay, so Oracle part 2 class class 33, and it's March. Okay, we'll start with the query. So we know what is inner joins now. We will start with the query, right? The query is going to be the query. Write a query to retrieve employees who are working in the Chicago location or London location. London. So if you look at this query, I'm not going to give this query directly. Okay, this query will not be given to you directly. They give this query by assuming that there are two tables. So one table is employee table, the second one is like department table. So there will be two tables. One table is employee table, second one is what, department table, right? And you have the department number as the common column in both the tables. This is the what this is the assumption. The department number is common to employee table as well as it is common to department table, right? These both columns are available in both tables, right? But you want to find employees. What you want to find? Retrieve employees. You want to find retrieve employees in the sense it can be what? It can be a employee name. Okay. You want to retrieve employee name. Employee name is part of EMP table, and location is part of what? Location is part of department table. Hope you are able to understand. Firstly, to do this, you need to join these two tables. First of all, you need to join these two tables by using a join. Firstly, we will understand to join these two tables. How we can join these two tables? How we can join these two tables? By using we have to consider the common columns in these two tables. What are the common columns? So department number is the common column. So by using this common columns, we can join these two tables. Let me open the SQL plus so that you understand this SQL plus. IDB 7 a.m. DB 7 a.m. Okay, login has been successful, right? Now let me set page size 100. Set the lines. Okay. Select star from EM. This is the employee table, right? Select star from department. So this is a department table. What I want to do, I want to find the employees who are working in the London location, right? Always remember, okay, you are going to deal with when you're going to deal with two different tables. Try to find the common column name. So for the employee, the common column name is department number, DEPT number, and for the in the department table, okay, the common column is also DEPT number. So first we will write a join query, okay, by using this common column name. So I can write. I can say select name. Okay, let me select star from what EMP. Okay, inner join key I need to use inner join, right, followed by DEPT. So I am let me include the alias name also, EMP space E, DEPT space. So E is an alias to EMP, D is an alias name to DEPT, right? On, okay. So E dot, what is a common column? DEPT number equal to here D dot DEPT number. So now both tables are joined together, right? Okay, if you see both tables are joined together. So department, the employee table and the department table based upon the given condition, right? Now what we want to do, we just want to find the employees, right? I just want to see, just want to see the employee name and the location. Location should be Chicago. Okay, first let me extract, let me see only these two columns. I will be seeing employee name and the location. Okay, but I want to find the employees who are working in the London location, right? So at the end of, okay, after the join query, okay, while joining this, only join the tables who are working in what, who are working in the London location. So I would say, and LOC, and the location is something like London. Okay, joining condition and followed by what, London location. At the time of joining the table, we have seen this example in the last class. At the time of joining the table by using the department number, right? It will also check, okay, if the department number is affiliated with the London location. Okay, only such data will be required in retrieved. Mike, Emily, and Oliver. This is the query. Right? See, after writing two queries, you will get these things grip. Okay. Write a query. Next question. To display what? To display. Now I want to say, okay, what I want to do? I want to write a query to display. Okay, let us do this. Let a query to display sum of salaries. Sum of salaries of each department. Each department name wise. I want to find the sum of salaries of each department name wise from which tables? From employee table and department tables by using equi or inner. This query is going to be very interesting. Okay, so they have given the tables, employee table and department table. It means we are going to deal with the same set of tables, right? And you know the common columns, department number and the department number are common. So always remember, now in this case also, by using the department number, we are going to join two tables. After joining two tables, what we are supposed to do? We are supposed to find, okay, this is the actual query. Sum of salaries of each department. We're supposed to do what? We're supposed to find the sum of salaries of each department. Okay. Always remember to first of all, how to join two tables by using the common columns. We know what are the common columns. Firstly, let us try to do this. Okay, let me do this. Okay, this is going to give us what? This query is going to give us join two tables. Two tables are joined. What they want us to find? They want us to find sum of salaries of each department. So how many departments are there? You see, you have multiple departments and duplicate department also. Software engineer, project manager, HR, marketing, AT, BA. So many things are here. So many things are here, right? I need to group it. I need to extract only the unique departments, right? Unique departments. I want to extract. I want to extract what? I want to extract unique departments. So what is the actual question? I'm sorry. The sum of salary of each department, right? I want to extract the salary of unique department. Firstly, what I want to use, if I want to extract this, I can go for what? I can go for group by clause. There is some clause like group by, if you remember or not, group by expression. If you use group by, okay, you get all the individual departments. So what are the departments that you have that will be grouped and collected individually? So there will be no duplicates. Like you will be getting software engineer, you will be getting AT, you will be getting HR, you will be getting marketing, things like that. without any duplicates. First thing you can do, you can use a group by expression at the last. Okay, after joining the table, okay, what you can do, you can use what? You can use the group by expression so that all the data will be segregated. At the last, you can use group by. Okay, group by, you can say what? You can say in our example, it is job, group by job. Let us do that. Let us do group by job. Okay. Same query at the last, I'm using group by. Okay. If I do this, what it is saying, not a group by expression, and it is pointing an error here. It is pointing an error. Star is not a group by expression. You remember or not, in our previous class when we were discussing about group by expression, the expression that you are taking here should be the same column you have to select here. What I mean? The expression that you are taking here should be the same column. Okay, the column name that you are taking after the group by should be the same that you have to place here. Right? There is a mismatch here. Okay. So you are taking a column name as job here, but you are using star here. Both should match. If you are taking job, you should select the job column. Right? Let us do that. Let us go according. Let us go according to the suggestion given by this SQL command. Okay. Select job from. Okay. There is a complete inner join query and followed by the group by expression. Okay, now all the jobs are segregated. There are no duplicates. All the jobs are segregated. I want to find the sum of salaries in each and every job. Okay, for software engineer, if you see software engineer, what is the salary? Here you have 10,000, and there is another software engineer, I guess here. Here you have what? 76,000. Okay, it should be 86,000, I guess, isn't it? How I can achieve this? Simply adding, okay, next to job column, you need to use a function, aggregate function. What is that? You can use what? You can use something like the sum function. Okay, what you want to sum? You want to find sum for what? Sum of salaries. Sum of passing the salary column. Sum of salary column. Okay. Now, will this give the actual answer? Let's see. You get for each and every job, right? The total salary you have got it. Right? So this group by expression has been discussed already, right? We are just trying to do the expected, write the expected command, accepted query. You're using job here, it should be, you should select the job here in the beginning. Followed by, you can add any function. So in this case, I am adding the sum function, right? You can add any function, and if you want, you can add the count function also. So how many members are there in every job? So things like that you will get. Count star. You will get. And these things are discussed already. If you just practice this once, you will get this. This is the query. The next one. What is the next query is? Next example. Okay. Write a query. Write a query to display. What else we can do? Okay, to display department number, sum of salary, in each department from employee table and employee table and department tables by using equi or inner join. Okay, so this query, if you see this both the queries, there is a one small difference in this query and in the previous query. One small difference is there. In this query, you are finding sum of salary of each department name. So the name of the column is job column. Okay. But here I am expecting to find the sum of salary in each departments from employee. So I'm expecting what? I'm expecting the department number column. Okay. Summation should be happening on the department number column, and here summation is happening on job column. Can I write the same query and just like that and just make the changes here as department number and department number? Let's see what will happen. Okay, what is the first major step? What is the first step that you have to do? We have to perform what? We have to join two tables first by taking the common column name, right? Department number. Let us do that first. Okay. So this is the joining query. Okay. After joining two tables, what I'm expecting here, right? I want to, instead of selecting, so okay, I will be expecting what? Group by function to segregate all the department numbers. I want to segregate departments number. Okay, I will segregate department number. If I am using department number after the group by expression, I am supposed to use the department number here also. First thing. Okay, the second thing is I also want to display what? I also want to display the department number along with the department name. So if you see the table, okay, this is the department number. Okay, and department name in our case it is like, so this is the department name. Department name is part of what? Department name is part of the department table. D name, you have something like, you know, D name, isn't it? Department number comma department name, right? I am also taking the same after the group by expression. I am taking the same thing here. Let us see what will happen if execute this query. Okay, so instead of star, okay, I have to use the group by department number, department name. The same thing I'm using here. If I run this query, there will be a problem. I will tell you what is the problem. Okay, see, it says column ambiguous defined. So the line number one, see, it says, look at the star is pointing here. It says there is an ambiguous. What is this ambiguous? Ambiguous is meaning for a confusion. Ambiguous means there is a confusion. What kind of confusion is here? Very simple. You see department number, there are two department numbers. Column name department, you are saying department number, but there is no specificity here because department number is here as well as department number is here also. There are two department numbers. The query, okay, the SQL will not understand, the database will not understand which department number you are referring to. So that's why it says that is an ambiguous. I want to be very specific which department I am referring to. I want to be very specific. Which department I am referring to. In order to see, guys, duplicates are available. No, when I say department number, which department number it will take? I am saying department number, but in our table there are two department numbers. Which department number it will take? Which department number you are referring to? Duplicates are available. No, duplicate columns are there. If you are using the duplicate columns, you have to ensure that it is very specific. You need to find a way to ensure that it is going to be very specific. Right? What else I can do here to avoid this? What else I can do? I can just use If I want to refer the department number of DEPT table, right? What alias name that I'm using here? Alias name is D. If DEPT D. I can use what? D.DEPT here. Okay, now it is clear that I am referring to the department number of DEPT table. Problem solved. Right? Let us do that. When I say D.DEPT table, we are thinking that the problem is solved. Okay, again there is a problem here. Okay, here you are using D.dpt number. You are completely referring that it is the department number of DEPT table. What about this department number? Again there is a problem. What about this department number? Okay, there are two department numbers here and here. Which department number this is referring to? I should also specify here. Here also I am referring to department or department number, and there also I am referring to DEPT. I will be using the alias name here as well. D dot department number. So this D is referring to the department number of DEPT table. DEPT table. This D is referring to the department number of DEPT table. Now the problem is solved. The ambiguous situation is solved. Ambiguous is confused. Okay, now, okay, you got what? Department number 10, department number 20, department number 30. Data is segregated, right? And you are getting the equivalent department name. What is my question? My question is to find the sum of salaries, isn't it? My question is, at the last, my question is to find what sum of salaries, right? I will be just using a grouping. I will be using a function after these two columns. The function is going to be what? The sum function. Sum of salaries. Okay. Now we will get salaries with respect to each department numbers. Okay. And I have also mapped their department names. Department names also I have mapped. Okay. And the equivalent salary will also be displayed. This is the complete query. We are building the query step by step. That's it, nothing else. Okay, first build the query by using to join the two tables. Okay, next use the group by expression. After using the group by expression, you can use this sum. Okay, this is the first step. What is the first step? Okay, inner join. Okay, the joining is the first step. Okay, so this is step number. This is step number 1, and grouping by. Okay, so this is the step number 2. After grouping it, add the respective function which you want to do. This step number 3. That's it. First join the two tables. Second, use the efficient grouping by a function. This is 2. This comes under 2. This comes under 3. That's it. It is all about what? It is all about the how to join two tables by using inner join. Okay, let us take one more example. Last example. We will have all the combinations. Okay. Write a query to display departments, in which department, okay, the number of employees are less than 5 from employee table, department tables by using join or inner join. Okay. Let a query to display departments, in which department number of employees are less than 5. Okay. First look for the table names, employee table, department table. So we need to use the joining query. After joining this, what we have to do? We have to display the departments where number of employees are less than 5. Where number of employees are less than 5. But firstly, a simple join query. So we know what is a join query. Okay, this is the join query. It is going to join two departments. Okay, after joining the query, only one group by expression you will add. Okay, at the last, you will add group by expression, right? You will segregate what? You will segregate the department name. Display departments. Okay, so department name. So this is the job, and this is what? This is in our table. I have taken the job as the department name column. Okay. Grouping by expression should also be what? Job. After the grouping by, I'm using job, so also what? This is also job. I will just use what? I will just ask the count. So TS one count, SC two count, HR one count, PM one count, marketing one count. So I'm getting like this, right? So what I will be doing after getting this, I want to find okay, instead of let me take department name so that our query, you can take any common column, okay, because you have departments in DEPT table as D name. Okay, you have departments in employee table as job. Let us see what will happen if you take department name. D name. Okay. If you take the department name, it says HR you have 3, SC you have 4, PM you have 3. Okay, I'm changing the query. I want to find the count on which department their employees are less than 4. Okay. So at the last, I will be using what? I will be using the having expression saying that count, find the count if the count is what? If the count is less than. Okay, I will explain this query. Okay, this is the actual query. So firstly, I have used the the join statement to join two tables. Okay, followed by, okay, I'm using the grouping by clause to segregate to group the department department name. Okay, after the grouping, okay, what happens? The department name will be grouped, right? D name will be grouped. Okay, D name will be grouped. After grouping, okay, you are finding what? You are finding the count. Finding the count. In our example, what is the count? You have HR, you have SC, and you have PM. Only 3, right? You have HR, you have SC, one, you have PM. Right? This is group. This is going to give you the count of how many HRs, how many SCs, and how many PM, which is going to give by using this count function. You will get the individual count. What is the count that you have got here? The counts are like 3, 4, 3. Yeah? You get 3, you get 4, you get 3 here. Okay, this is the whole, this is what you're getting it as a result. After this, right, you're using what having clause. Because you can use having clause. If you want to use where clause can be used before group by function. But having clause, if you want to, after getting these results, if you want to make any additional aggregate functions, you can go for what? You can go for this having clause. This can be used after the grouping by expression. I'm using having, again I'm saying count. If the count is, total count is lesser than 4, I'm saying. Now it will fetch the records, okay, which the count is lesser than 4, right? So this is matching, HR is matching. Okay, this will be given. Okay, and this is 3, right? Why did I take 4? This is 3, isn't it? 343. Okay, this 3, this 3. Right? This will also be taken. That's why output you get what? HR3 PM3. That is what displayed in the console. HR3 PM3. Okay, this is the complete expression, right? Now what I can say, what I can conclude. Now we got to know what is the grouping by function. But I have a doubt here. What kind of doubt I am getting now? We know what is the inner join now. We know what is inner joins and equijoins, but there is a problem here. What is the problem? If you see, let me take the course table. Select star from course. Okay, this is a course table. Select star from department. This department table. Okay, I can join these two tables based upon the common column. So not department, guys. Students. Let me take students. Course and the select star from course. Select star from. I have course table. I have student tables. Okay. If I want to join these two tables, I will be joining based upon the course ID, CID. Okay. But when I use inner join, I always get what? I always get the matching records, right? So this one will be mapped to this. When I use inner join, this is what I get. Inner join will ensure that I am going to get only the matching records. What is the matching records? This one will be joined. This one will be joined. 1 minute, guys. 1 minute. Okay, when I use inner join, okay, it is going to give the matching. It is going to join two tables based upon the matching row. So this is the matching row. 1 is matching, right? And 2 is matching. And unmatched rows are left like that. So this is unmatched rows, and this is also an unmatched row in students column, students table. This is also an unmatched rows in course table. These are going to be left. It's going to be left. I want to deal with. I want to display this data also. You cannot display this data by using what? By using inner joins. Inner joins, by using inner joins, it is not possible. So what is the way that I can do? Okay. Then you will be using a concept of what? Outer joins will be using. What I can say here, okay, please be informed that by using equijoins or inner joins, we are retrieving matching rows. Matching rows only. But if you want to take this, if you want to retrieve both matching and unmatching rows from multiple tables, then we have a technique, have a concept called as outer joins. Okay. So I'm going to introduce about what? Outer joins. Outer joins. For usage, outer joins are used to retrieve matching, unmatching data. from multiple tables. First thing. Okay, and again there are three types of outer joins. The first one is you have something like the left outer join. Second one is you have something like the right outer join. And the third one is you have something like what? The full outer join. Full outer. Okay, the left outer join. First of all, let us discuss about the left outer join. Outer join. Okay, so it tries. Okay, it tries matching rows from both the tables, but unmatching rows from the left side of the table. What does it really mean? To understand this, let me let me see the example. See, I want to join these two tables. Always remember, to join any two tables, consider the common column. CID is the common column and CID is the common column. Typically, how we will be joining by using inner join? If we use select star from what? Use select star from course or anything you can take, or course. Let us take course C, right? Inner join students S, right? On C dot PID is the common column name equal to S dot SID is the common column. Did I do any mistake? Dot both tables are joined, right? But what I want to do here, okay, I want to use what? I want to use the outer join, the left outer join, left. Okay, the moment I start using the left outer join, now you see the result. Okay, see, I have taken the course table. Okay, this is the left outer join. This is join key of left outer join, right? Towards its left side, I have taken the course table, and towards the right side, I have taken the student table. Okay, left outer join says include the matching records, okay, and the unmatching records. Right? If you see the course table, you have Oracle, you have Java, you have .NET, and you have Python. Right? Firstly, it will retrieve all the matching data with respect to the next table. Right? Then it will retrieve the unmatched data. So Oracle and Java are taken. Oracle is taken and Java is taken. But this .NET is not a matching record. Python is not a matching record because these entities are not there, not taken by any students. So this is called as what? Unmatched records. Unmatched records will also be displayed at the end. Okay, so when I see, let me copy this query, paste it here. Okay, now with respect to this join key, so left outer join is the key, right? When I say left outer join, it will extract only the matching record of the table that you are mentioning in the left side. You're mentioning in the left side. So in my case, I'm mentioning the course table in the left side. Only the matching unmatched records of the course table will also be retrieved. But the unmatched records of student table is not retrieved here because you're using left outer join here. If I want to display the unmatched records of the students table, I can simply, do the inversion here. What do you mean? If I place student table here instead of course, if I place students here, students yes. If I place course here, course here, right? Now you see unmatched record of student is displayed. Okay, in the column, okay, it is null for because you're using left outer join. Now with respect to this join key, what is the table that you have mentioned towards its left side, student table? So you get the matching records of student table and unmatched record of student table by using left outer join. Right? Example, outer join and left outer join. Okay, you can change the order, I can say. So this is the order. The table that you're keeping in the left side. Okay. So those matching records as well as the unmatching records will also be retrieved. The table that you are keeping in the right side, only matching records will be retrieved. Right? For the unmatching records, that is mapped from the from its joining table, they will be having the null values. Okay, nothing will be there. Null values will be there. And this is the ANSI format. You want to do the same thing in non-ANSI format. So this is in the form of what? ANSI. This ANSI. ANSI format. If you want to do the same thing in non-ANSI format, so I have said that in the non-ANSI format, you should be using the where instead of what? Instead of on, you should be using where on ANSI. Okay. Same query. Difference between ANSI and non-ANSI is that should not be on. Instead of on, you should be using where. Okay, and there should not be any join key. Okay, but if you use this, there is a problem. Okay, we use this by separated by comma. If you use this, there is a problem. Okay, by default it will be treated as what? Inner join. But I need to differentiate this. For the non-ANSI format, I said already that the only difference between ANSI format and non-ANSI format is what? You will not be using this join key. Join key cannot be used. Instead of join key, you will be using this. You will separate these two table by comma. Instead of or, you will be using the var clause. But you do that, by default it is taking it as an inner join. But I want to do the left outer join by using the non-ANSI format. How I can do that? Simply by using a operator called the predicate operator, the plus operator. Okay. If I place plus operator, if I place plus operator here, now this is going to act as what? The left outer join. Sorry, right outer join. For example, I use the plus operator next to this course table. I'm using it on the left side. Okay, this is equal to operator. I'm using it on the left side. I'm using it on the what? Left side. Right? Now you get what you see. If you see the results, result itself says that okay, you're using the student table here. Okay, 1 minute, guys. S dot cid c dot cid. Okay. Please be informed that you can keep the left outer join by using the predicate operator or plus operator. Using the plus operator. Okay, and if you use this plus operator, 1 minute. We use this plus operator towards the right side. After the equal to operator, we use the plus operator towards the right side. Okay. This will be treated as what? Left outer join. Left outer join. Okay, and the same plus operator, if we use it on the left side. Here, left side means here. Will be treated as right outer join. This is the only difference. This is how you differentiate. Because since there are no join keys, you depend upon this plus operator or predicate operator. When you use it on the right side, this left outer join. Okay. All the matching and unmatching records you will get for the students table. When you use it on the left side, okay, all the matching and unmatching record for the course table will be retrieved. Just replacing this as over here. This is the way you can achieve this by using what? By using the non-ANSI format. By using when you want to use the non-ANSI format queries. And the next thing we have what? Right outer join. This should be our right outer join. So what is this right outer join? Same thing. Okay, I can copy the same query, same explanation, and paste it. The only difference is instead of left, okay, instead of using the left here, I can use what? I can use right. Right side of the table. Right outer join, right? Same thing. Right outer join. See? Now you see, this is the right outer join key, right? This is the course table, right? Towards the right outer join, it will look for the right hand side table, which is a course table. It will retrieve the matching records and the unmatching records. The only change is what? Only change is the key. Only change is the what? Key. This is for the ANSI format. Okay. For the non-ANSI format, the same thing that I have explained before. You will use the plus operator, okay, in the left side. Plus operator on the left side, and you will not use the this for non-ANSI, and for the ANSI, the plus operator will come into the picture. Okay, where you will be using the plus operator to for the right outer join on the left side. Okay, plus operator will be using on the left side, and you are not supposed to use the on. Instead of on, you will be using the var clause. There should not be any join key. Instead of join key, you will use what? You will use a comma to separate two tables. Right? This is what the right outer join. Okay. Next one is we have what? We have full outer join. Full outer join is it is going to retrieve the matching and unmatching records of both the tables. Full outer joins. It is going to retrieve the matching and unmatching rows or records from both the tables. Example, same example we can take. Okay. If I use, instead of right outer join, if I use full outer join, now the both the tables matching records as well as unmatching records will come into the picture. Okay. For the student table, matching records and unmatching records are joined, right? And for for this what we call it as, for the course table you have unmatching records, and for the student table you have unmatching records. This is what this is what for the full outer join, right? We want to apply this full outer join for the non-ANSI format. Okay, can I use, ideally what you will be thinking, usually what you will be thinking, you will be thinking like we use plus operator on both the side. You can achieve that. Whatever thought, use plus operator on the both side, on the both the sides, and instead of one, if you use the var clause, and if you remove this the joining key is like this is the joining key, and if you replace that with the comma, that you would be thinking that you would be achieving this. It says a predicate may reference only the outer. You cannot use this. Okay, this is not the conceptual thing. You cannot use two predicates at once. These predicates are used to differentiate between left outer join and right outer join based upon its placeholders with respect to the equals operator. If you put the predicate towards the left, it is considered as right outer join. Towards right, it is considered left outer join. You cannot use both. There will be an ambiguous situation. It says, instead of doing this, what I can do something like this. I can take what? Take select star from students S, comma, course C, have S dot CID, okay, plus this is the right outer join equal to C dot CID. Okay, I have taken, so what I am doing here, I have taken the right outer join separately. I'm going to take the left outer join separately. Okay, so now this is the result of right outer join, this is the result of left outer join. I want to join these two tables. I want to join the resultant tables. Previously we have discussed something about this union function, right? Union, right? If you have one query, you will just use the union operator. Union operator followed by what? Union operator followed by the another query. Just going to join two tables without any. This union operator is joining this table followed by this is combining two tables together. Union means what? It will join will include the duplicates also. It will join the duplicates also. We have discussed this in the previous classes. By using this, we can achieve full outer join for the non-ANSI format. This is the example. Union key union is going to come into the picture. Play the title. We use union. Combine two tables. Two tables. And what is the query? This is the query. Union. Okay. So tomorrow we'll discuss about what? Tomorrow we'll discuss about the non-ANSI joins. That will also be interesting. Non-ANSI. Non-ANSI, not non-equi joins. Non-equi joins, where you will be using operators like greater than, lesser than, greater than equal to, lesser than equal to, okay, not equal to operator, not equal to, between operator. Why? Because for the equi joins, you are able to use only the equal to operator. Only this equal to operator. Everywhere you are using the equal to operator to join two tables. But for non-equi joins, apart from equal to operator, you are allowed to use the operators like remaining operators. You are eligible to use the remaining operators in non-equi joins. That will be also be very interesting. Okay, let's connect tomorrow. Thank you.